Good day, everyone. Welcome back to the Liceo Math Club YouTube channel. Before we begin the lesson proper, let me ask you this question. Have you ever wondered how weather forecasts work? What concept do you think they use? If your answer is probability, then you're correct. In this session, we are going to talk about probability, the study of chance. At the end of this tutorial, the students are expected to illustrate a random variable, distinguish between a discrete and continuous random variable, illustrate a probability distribution for a discrete random variable and its properties, and compute probabilities corresponding to a given random variable. So, let's get started. The first term that we need to keep in mind is random experiment. It is a type of experiment that produces a definite outcome, yet it cannot be predicted with certainty. As the term implies, it's random. An example of this event is when we toss a coin. It has a clear outcome of either head or tail, but we have no way of knowing which will show up. These possible results, the head and tail, are referred to as sample space. The sample space is the set of all potential outcomes of an experiment. For instance, as I've said earlier, when we toss a coin, its sample space is head and tail. When rolling a die, the sample space is 1, 2, 3, 4, 5, and 6. The next term we need to keep in mind is a random variable. It is a quantitative variable whose value is determined by the outcome of a random experiment. In notation, we use a capital letter, let's say X, to denote a random variable, and the corresponding small letter x for one of its values. We have two types of random variable. The first one is the discrete random variable. These are variables that can take on a finite number of distinct values. Keep in mind, they are whole numbers and can be counted. Again, they are whole numbers and can be counted. Examples are the number of students in a class, number of cars sold in a day, and number of houses in a block. On the other hand, a continuous random variable takes an infinite number of potential values. They are usually measured, thereby can be expressed in decimals. Again, unlike discrete random variable, they are usually measured and not counted, and thereby can be expressed in decimals. Examples are a person's height, body temperature, and price of a laptop. Let's have these exercises. Tell whether each random variable is discrete or continuous. Number 1. Altitude of a mountain. The correct answer is continuous. Number 2. Number of times you ask questions to your teacher. If your answer is discrete random variable, then you're correct. Third, thickness of a book. The answer is continuous random variable. Number 4, amount of liquid in a glass. Like number 3, it is also a continuous random variable. And lastly, Head counts of animals in a zoo. This is considered to be a discrete random variable. Okay, you did a great job, everyone. Now, let's focus more on a discrete random variable. There are two ways of presenting this type of variable, and that is through the probability distribution and probability histogram. Probability distribution of a discrete random variable. It is a table of values that shows the probability of any of the outcomes of an experiment. It tells all of its possible values, x, along with their associated probabilities, p of x. To get the probability p of x, take note of this formula. P of x is equals to number of times x occurs divided by total number of possible outcomes. Take a look at this example. There are 5 blue marbles, 3 red marbles, and 2 yellow marbles in a bag. Construct a probability distribution for the day. Here in our table, the first column is composed of the sample space, which is the marbles of different colors, blue, red, and yellow. In the second column, we compute the probability of each color using the formula provided. For the blue marble, we have 5 over 10, since there are 5 blue marbles out of 10. Where did we get the denominator 10? Go back to our formula. It says here the number of possible outcomes. So all we have to do is add this 3, 5 plus 3 plus 2 equals 10. Thus, for the red marble, we have a probability of 3 over 10, since there are 3 red marbles out of 10. The same goes with the yellow marble. We have 2 over 10 or 1/5 in lowest term, since there are 2 yellow marbles out of 10. I hope everything is clear. Now let's discuss the properties of discrete probability distribution. First, the probability of each value of the random variable must be greater than or equal to 0 but less than or equal to 1. Or if you're having trouble understanding this symbol form, it simply means that the probability of each value of the random variable must be between or equal to 0 and 1. Next, the summation or the sum of the probabilities of the random variable must be equal to 1. Okay, let's go back to our example here and check if this table satisfies the properties of a discrete random variable. Let's first check the probability of each random variable. It must be between or equal to 0 and 1. As we can see here, we can glean that 5 over 10, 3 over 10, and 2 over 10 are all between 0 and 1. So first property, check. Next, second property, the summation of the probabilities of all random variable must be equal to 1. So all we have to do is add this 3. 5 over 10 plus 3 over 10 plus 2 over 10 is equals to 10 over 10 or 1. Thus, second property is also checked. This simply means that this table here is indeed a discrete probability distribution. Let's move on to the next way of presenting the random variable, that is through probability histogram. Probability histogram is a graphical representation of a probability distribution. As you can see here, it displays possible values of a random variable along the horizontal axis or x-axis, and the probabilities along the vertical axis. The rectangles are constructed so that their bases of equal width are centered at each value of x. Heights are equal to the corresponding probabilities given. In this case, the probability that we used are in decimal form. To apply all the concepts we learned, let's try this example. Below are the points scored for a total of 20 points by 10 students selected randomly in a monthly test. Let x be the points scored. Construct a probability distribution and histogram. The first column contains the points scored by the students. In the second column, we compute the probability of each sample space. For the first outcome, there are 3 out of 10 students who scored 15. Thus, the probability will be 3 over 10, or if we convert it into a decimal, it would be 0.3. 2 students get a score of 16, which derive the probability of 2 over 10 or 1/5 in lowest term. Or if we will convert it into decimal, it will be 0.2. Is followed by 1 student who scored 17 and 18 each, which resulted to 0.1 probability. We have 0.2 for 19 as there were 2 students who scored 19, followed by 1 student who scored 20, which resulted to 0.1. As per the probability histogram, the horizontal axis displays the points scored or the x value. We have here 15, 16, 17, 18, 19, 20 as reflected in our probability distribution. Along the vertical axis, it portrays the probabilities of each sample space. In this case, we utilize the decimal. So we have here 15, then 0.3, 16, 0.2, 17 and 18, 0.1, 19, 0.2, and 20, 0.1. Now, let's try to answer these following questions. What is the probability that a student will get at least a score of 18 in the monthly test? Or in symbol form, what is P of x if x is greater than or equal to 18? To solve for this, we need to simply add the probability of 18, 19, and 20. Therefore, P of x for x is greater than or equal to 18 is equal to P of x for x is equal to 18 plus P of x for x is equal to 19 plus P of x for x is equal to 20. Then, substitute the values of 18, 19, and 20. We have here 0.1 plus 0.2 plus 0.1 is equal to 0.4. So the final answer for this question is 0.4. I hope everything is clear. Let's move on to the next one. What is the probability that a student will get a score of at least 16 but less than 19? Again, at least 16 but less than 19. So if we will translate this question into a symbol form, this will be the result. What is P of x if x is greater than or equal to 16 but less than 19? To avoid confusion, let me clarify. When we see this symbol here, and here the one with the underline, since this underline means equal to, it signifies that the number beside it, like 16 and 18, should be included in the solution. But if the symbol is only less than or greater than, then there's no need for the number beside it to be included. In this sense, for this question, we need to add the probability of 16, 17, and 18 only. So we have here P of x, where x is greater than or equal to 16 but less than 19 is equal to P of x, where x is equal to 16 plus P of x, where x is equal to 17 plus P of x, where x is equal to 18. Then substitute the values. We have your 0.2, 0.1, and 0.1. So 0.2 plus 0.1 plus 0.1 is equal to 0.1. Alright, that's all for today everyone, and I hope you've learned a lot. Thank you for watching and keep safe.